When selecting medium voltage cables, several resources are available to guide you. Books offer in-depth knowledge. Consider the book Medium Voltage Cable Engineering by H. M. Ryan, the Medium Voltage Electric Cable Handbook by Vladimir Gurevich, and the Cable Reference Book by NEMA, the National Electrical Manufacturers Association. Technical papers provide specific application guidance. Look at the Medium Voltage Cable Selection and Application Guide by Eaton. Another resource is Medium Voltage Cable Selection and Installation by Endeavour Energy. You might consider the Medium Voltage Cable Selection for Wind Turbines by Segre. Industry standards are crucial for ensuring safety and compliance. IEEE Standard 1584.2018 Guide for Selecting and Installing Medium Voltage Cable Systems provides detailed guidance. Also, IEEE Standard 579.2019 Recommended Practice for Polymeric Insulated Medium Voltage Power Cables for Use in Cable Distribution Systems, and IEC Standard 60502.2 Cables Electrical cables with extruded insulation for rated voltages above 30 kV up to and including 150 kV are very helpful. Several online resources can simplify the selection process. Check the Medium Voltage Cable Selection Guide by Cable Organizer. Also consider the Medium Voltage Cable Selector by Hubbell Power Systems and the Medium Voltage Cable Catalog by Sarah Wire. Finally, it is helpful to check the cable manufacturers' websites. Some manufacturers of cable include Prysmian Group, General Cable, Nexans, Southwire and Eaton. When choosing a medium voltage cable, consider several factors to ensure optimal performance and safety. Firstly, determine the appropriate voltage rating. Medium voltage typically ranges from 2.4 kV to 69 kV, but it is crucial to select a cable rated for the specific voltage of the system. Secondly, consider the current carrying capacity or ampacity of the cable. This must be sufficient to handle the maximum load current without exceeding the cable's temperature rating. Consult NEC, National Electrical Code, tables such as 310.15 to determine the appropriate ampacity based on cable size, insulation type, and installation conditions. Thirdly, evaluate the insulation material. Common insulation materials for medium voltage cables include cross-linked polyethylene, also known as XLP, ethylene propylene rubber, known as EPR, and high molecular weight polyethylene called HMWP. XLP offers excellent electrical properties, moisture resistance, and is suitable for a wide range of applications. EPR provides superior flexibility and is often preferred for applications with frequent bending or flexing. HMWP offers good abrasion resistance and is commonly used for direct buried installations. Fourthly, consider the shielding requirements. Shielding is essential for containing the electric field within the cable and minimizing interference with nearby equipment. Medium voltage cables typically employ metallic shielding, such as copper tape or aluminum wire shields. The shield must be properly grounded to provide a low impedance path for fault currents. Fifthly, consider the environmental conditions. Factors such as temperature, moisture, chemical exposure, and mechanical stress can affect cable performance and longevity. Select cables specifically designed for the intended environment. For example, cables installed in wet locations should have moisture-resistant insulation and jackets, while cables exposed to chemicals should be resistant to those specific substances. Sixthly, check the installation method. The installation method can significantly impact cable ampacity and overall performance. Common installation methods include direct burial, conduit, cable tray, and aerial installation. Direct burial offers good heat dissipation, but requires proper backfilling to prevent mechanical damage. Conduit provides mechanical protection and allows for easy cable replacement, but can reduce ampacity due to limited heat dissipation. Cable tray is suitable for supporting multiple cables and provides good ventilation. Aerial installation is cost-effective, but requires careful consideration of wind and ice loading. Seventhly, check the conductor material and size. Copper and aluminum are the most common conductor materials for medium voltage cables. Copper offers high conductivity and corrosion resistance but is more expensive than aluminum. Aluminum is lighter and more cost-effective but requires larger conductor sizes to achieve the same ampacity as copper. The conductor size must be selected to meet the ampacity requirements and minimize voltage drop. Eighthly, select the appropriate cable construction. Medium voltage cables are available in various constructions, including single conductor, multi-conductor, and shielded or unshielded configurations. Single conductor cables are typically used for high current applications, while multi-conductor cables are suitable for three-phase systems. Shielded cables are recommended for minimizing electromagnetic interference and ensuring personnel safety. Ninthly, consider the cable accessories. Cable accessories, such as terminations, splices, and connectors, are essential for ensuring reliable cable connections. Select accessories that are compatible with the cable type and voltage rating, and follow the manufacturer's instructions for installation. Terminations provide a secure connection between the cable and equipment, while splices are used to join two or more cable sections. Connectors are used to connect cables to transformers, switchgear, and other electrical apparatus. Tenthly, comply with industry standards and regulations. Medium voltage cable selection and installation must comply with relevant industry standards and regulations, such as the NEC, IEE, and ISIS standards. These standards provide guidance on cable ampacity, insulation requirements, grounding, and other critical aspects of cable system design. Failure to comply with these standards can result in safety hazards, equipment damage, and code violations. 11thly, check the short circuit current rating. Ensure the cable can withstand the maximum short circuit current that could occur at the installation location. This rating is determined by the cable's construction and materials. 12thly, check the voltage drop. Calculate the voltage drop along the cable length under full load conditions. The voltage drop should not exceed the allowable limit specified by applicable standards to ensure proper equipment operation. 13thly, review the jacket material. The outer jacket of the cable protects the insulation and provides additional resistance to environmental factors. Common jacket materials include polyethylene, polyvinyl chloride, also known as PVC, and chlorosulfonated polyethylene, called CSP. Choose a jacket material that is suitable for the intended environment and provides adequate protection against abrasion, moisture, chemicals, and ultraviolet radiation. 14thly, consider the cable flexibility. Cable flexibility is important for ease of installation, especially in tight spaces or applications with frequent bending. EPR insulated cables typically offer better flexibility than XLP insulated cables. 15thly, check the temperature rating. Ensure the cable's temperature rating is appropriate for the operating environment. The temperature rating indicates the maximum conductor temperature the cable can withstand under continuous operation. Exceeding the temperature rating can degrade the insulation and reduce cable life. 16thly, consider the cable weight and size. Cable weight and size can impact installation costs and space requirements. Aluminum conductors are lighter than copper conductors, which can reduce the overall weight of the cable. Smaller cable sizes can be easier to install in confined spaces. 17thly, review the manufacturer's specifications. Always consult the manufacturer's specifications for detailed information on cable characteristics, performance, and installation requirements. The manufacturer's specifications provide critical data for ensuring proper cable selection and installation. 18thly, inspect the cable before installation. Before installing any cable, carefully inspect it for any signs of damage, such as cuts, abrasions, or deformation. Damaged cables should not be installed, as they can pose a safety hazard and compromise system reliability. 19thly, use proper installation techniques. Follow the manufacturer's instructions and industry best practices for cable installation. Proper installation techniques are essential for ensuring long-term cable performance and reliability. 20thly, perform routine maintenance and inspection. Implement a routine maintenance and inspection program to identify and address any potential problems before they lead to cable failure. Regular inspections can help detect signs of wear, damage, or degradation, allowing for timely repairs or replacements. When selecting medium voltage cables, consulting with experienced electrical engineers and cable specialists is highly recommended. These professionals can provide valuable guidance on cable selection, installation, and maintenance, ensuring a safe and reliable electrical system. Remember to always prioritize safety and follow applicable codes and standards when working with medium voltage cables. Neglecting safety precautions can result in serious injury or death.